Hello guys, welcome to my series, the ENSA or the Enterprise Networking, Security and Automation. This is a curriculum of Cisco version 7.0, and in this video I'm going to share with you the Module 2, the Single Area OSPF version 2 configuration. I'm going to divide this module into parts. This is part 1 because this module has a lot of subtopics. So let's move on. I'm going to show you my PowerPoint presentation. Alright, so this is part 1 of a module 2, Single Area OSPF version 2 configuration under the curriculum ENSA. In this module, as I said, I'm going to divide this into parts, part 1 and part 2, and possibly part 3. So the module title is Single Area OSPF version 2 configuration. The objective of this module is to implement the Single Area OSPF version 2 in both point-to-point and broadcast multi-access networks. The subtopics of this module are OSPF router ID. We're going to configure the OSPF router ID in the router, and point-to-point OSPF networks. So we're going to configure the Single Area OSPF version 2 in a point-to-point network. And then we have the multi-access OSPF network. We're going to configure the OSPF interface priority to influence the BDR election in the multi-access network. And then we're going to modify the Single Area OSPF version 2. And we have the default route propagation. We're going to configure the OSPF to propagate the default route. And the last is the verification or verify the Single Area OSPF version 2. So first part will be the OSPF version router ID and point-to-point OSPF networks. And second part are probably the multi-access OSPF networks. Okay, so let's start. First off is the OSPF router ID. So this is the OSPF reference topology that I'm going to use through the rest of my series, part 1 and part 2. This is the Cisco's curriculum reference topology to discuss the single OSPF version 2 configuration. So before we move on to the discussion of the OSPF router ID, I'm going to implement first this or I'm going to build this OSPF reference topology using Packet Tracer so that we can use this as a reference for our discussion. So if you notice, we have 3 routers. This is a single area under the area 0. So we'll be discussing later on what's the meaning of area 0 in a single OSPF point-to-point network. So in this particular reference topology, we have 6 networks. We have 10.1.1.4 connecting R1 and R2/30. So this is the gigabit Ethernet connection. And then we have R2 to R3 with the 10.1.1.8 network/30, and we have 10.1.1.12/30 network. So these are the router link. And then each router has an interface loopback address or the loopback interface, which is the virtual interface of each router. This will simulate local area network connection. And this is going to be interface. Loopback address is just a virtual address. This is not a physical address, physical interface of a router. This is used for troubleshooting purposes or just simulation of other network that is connected to each router. And if you notice, we also have a connection going out of the internet. And we have a loopback address also, L01. And we have a public IP address to simulate the wide area network connection using packet tracer. That's also an address to be configured later on or in the future video. We have 64.100.0.0 is last 30. Okay, so this is a connection also as a loopback interface going out to the internet. So let us do this OSPF reference topology. By the way, OSPF stands for, again, Open Shortest Path First, as I discussed in Module 1. This is an open standard routing, interior gateway routing protocol. So let us open the packet tracer. So I'm going to start a new connection because I already done this one. Alright, so I need 3 routers. I'm going to pick one router and then put it here. And then put it here. So I have 3 routers now. I'm going to change this name to R1 based on our topology. This is a packet tracer version 8. I'm using packet tracer 8.0. This is the latest version of packet tracer developed by Cisco for their Cisco Academy. Alright, so I'm gonna use an Ethernet port. I'm gonna connect using a straight through cable. Based on the topology, this is Gigabit Ethernet 0 to be connected to Gigabit Ethernet 00 also of router 2. And another one is from 001 to Gigabit Ethernet 01. And for the connection R3, I'm going to connect 00 to 001. Right? So we have now the 3 connections. And I'm going to draw a connection for the loopback address, loopback interface. And also from here, oh sorry, I need to connect from here. So that is our connection. Let me delete this area. Alright, so and then we need to type the network address. We have 10.1.1.4 here /30, and we have the connection here 10.1.1. This is .8. 10.0/30, and this is 10.1.1.12/30. And then we have an IP address also for the loopback address. This is 10.10.2.0/24, and we have 10.10.1.0/24 here, and we have also an IP address here 10.10.3.0/24. Okay, and then we're going to write the IP. This is .6, and this is .5. This interface is .10, and this interface is .13, and this is .14. This is .1. This is .9. It's also .1. We will also .1 here. Alright, so I think it's complete already, and we're going to name it as interface. This one is loopback address 0. This is also a loopback address 0. This is a loopback address 0. And then I need an internet connection here. I will use a cloud as the internet simulate our internet. Right, and we have, based on the topology, this is public IP. This is 64.100.0.0/30 also. Alright, so alright, so I think we're done. So we're ready to configure the interfaces of each router. Alright, so this is area 0. I need to write here, this is area 0. Alright, so okay, so let's start to configure the basic configuration of the router. Let's begin with router 1. CLI. Okay, so no initial configuration. So we are in the user, enable config T to go to global configuration mode, and then let us configure the interface 0/0/0, the IP address. This is 10.1.1.5 for router 1. Then the subnet mask 255.255.255.252, because that is /30. Then no shutdown, because by default the router interface is shut down. So now it changed to state to up. And then we'll configure the other interface, which is interface 1 of the same router. And then the IP address is .13, .14, and then same subnet mask. And then no shut. I'm using the up arrow here. All right, and then our interface loopback. Interface loopback 0. Okay, and IP address. IP address is 10.10.1.1, and then we'll use the 255.255.255.255. So we will explain later why we use 255.255. Enter. No need to issue shutdown because by automatically interface, the loopback address automatically changed to app. Right, so I'm gonna end, and then right. Oh, I forgot to config the host name. I need to put the host name R1. Then I need to issue no IP domain dash lookup, just to avoid the translating if you mistype the correct command. Okay, so end. I think that's it. And then so it changed to hostname R1 now. So WR is to save our router. Then let's proceed with router 2. The same CLI command line interface to configure the initial configuration of the router. No. So enable config t. Then host name, change the host name of the router to R2. No IP domain lookup. And then interface G0/0/0 also for R2. IP address. IP address is 10.1.1.6 255.255.255.252. No shutdown. And then another interface. Another interface is 01 for router 2. And then IP address of .9. I'm using up arrow just to make it faster. .9. And then no shut. Okay, so the interface loopback, back 0. IP address for loopback router 2 10.2.1 255.255.255.255. Okay, and then we'll save. Snap, and then router. So if you notice, the link between R1 and R2 already turned to green. That means they established communication. But router 2 and router 3 and router 3 to R1 is not still the triangle which indicates the signal or the packet still red because there's no communication yet because we didn't configure router 3 for their interface. So for router 3, CLI, no, enable configuration, config t, okay, hostname R3, and then no IP domain dash lookup. IP interface, the interface is G0 slash 0 slash I think that is slash 1 also. Let me check. That is slash 1. Yeah, slash 1. Router 3. So that is slash 1. Interface G0 just 0 slash 1. Then IP address. IP address is then that 10 255.255.255.252 no shot, and then another interface. This is that I think that is that 0 because that is 0, that's that 1. Let me check to make sure. Yeah, that's 0, that is that 0. And then interface IP address is that 13. Okay, so 13, no shot. Then the interface loopback 0. Interface loopback 0. IP address 10.10.3.1 255.255.255.255. Oh, it's wrong. 255, it should be. I forgot that here. Okay, so end. So, right. Let's see, show IP interface brief. So all our interface are configured. That 1013. Okay. So if you notice, let us check. So if you notice, all the triangle now turns to green. That means packets are already established. Signal already established between routers. Okay, so this is ready for the configuration of our routing protocol. But before we configure the routing protocol and the router ID, let's move on to my PowerPoint. Okay, so we're done with our OSPF reference topology that we're going to use for the demonstration. Okay, the first configuration that we're going to do in the OSPF configuration is the enabling the interface of the router for the OSPF version 2 using the command router OSPF. That is the command plus the process ID. The process ID that is in between, that this number are between 1 and 65,535, and this is selected by network administrator. The network administrator can select from 1 up to 65,535. That is a process ID. This is locally significant. You can use other number, but for the best practice is to use the same process ID for enabling the router OSPF, especially for Cisco curriculum. All right. So this is the first command that we're going to use, router OSPF 10 in global configuration mode, if you notice here. After entering this one, you will go to the mode config.router, and then if you want to know the sub command under this mode, you can just type question mark, and it will give you the sub commands that is available in this mode. Right? So this is the first configuration command that we're going to do it later. Okay, the next is the router ID. OSPF router ID, this is a 32-bit value, and this represented as an IP version 4 address. This is used to uniquely identify an OSPF router. And all OSPF packet includes router ID of the originating router. So this is very important because it will identify the router participating in an OSPF domain. You have to configure the router ID because router ID also includes inside the packet of the OSPF packets. And then every router requires router ID to participate in OSPF domain. It can be defined manually and automatically by the router. The router ID is used by an OSPF-enabled router to do the following. Number one, if you configure router ID, these are the most important purpose of this router ID. Number one, router will participate in the synchronization of OSPF databases. Because during the process, if there's an exchange state, if the router is already in the exchange state, the router can participate in the synchronization of the OSPF databases, which is built for each router. So, router ID is very important. Number two is, if you have a router ID, it will participate in the election of designated router. In a multi-access LAN environment, the router with the highest router ID will be selected as the DR. So router ID is very important in the election of designated router, because the router will pick the highest router ID as the DR in a multi-access LAN environment. And the second highest router ID will be assigned as the backup designated router, or the BDR. So DR, in this case, the designated router will be it will be the collection of all the updates, and is the one who distribute all the updates among the routers that is participating in the routing OSPF domain. Now, the router ID order of precedence. Cisco routers derive the router ID based on the following criteria. So the router will pick, or the router will automatically selected by the router by these three criteria. Number one, if the router is explicitly configured, or if the router is manually configured using the command router-id, the router will use this as use that as a router ID. If there is no configured router ID in the router, it will go to the next step, which is this. He will search for the IP version loopback address. Okay, IP version loopback interface configured if there is no router ID configured manually. Now, if there is no IP version for loopback address that is configured, he will choose the next IP address, which is the physical address that is configured in the physical interface of the router. So these are the process of how the routers get his or use the router ID. All right, so now the configuration of loopback interface address as the router ID, which I've already done. This is the 32-bit subnet mask. This is the explanation why we use the 4.255.255 when configuring an interface loopback address 1. It should be configured. This is a 32-bit subnet mask. This effectively creates a host route. And the host route will not get advertised as a route to OSPF routers. So it will not get advertised if we use this subnet mask, 32-bit subnet mask. All right, so this is the configuration. Define the interface loopback address IP address. In this case, he used the router ID 111. But we use the IP address, the IP version 4 address as given in the reference topology. So after configuring, we can use show IP protocols, and then the pipe include router ID. And then it will show you the router ID of the particular router. Now, in configuring router ID explicitly, in our reference topology, the router ID for each router is assigned as follows. So in this particular, for the purpose of this demonstration, the router ID used in this topology is, if that the host name is R1, the router ID is 1.1.1.1. This is still a IP version 4 format. And router 2 is 2.2.2. They use these router IDs for the purpose of, for simplicity. But you can use other router ID as based on the IP version 4 format. So use the router ID. This is the command, router ID, and then the router ID. Configuration mode, manually assign the router ID. So this is the command, router OSPF, router ID 1-1-1-1. And okay, so let's move on. Let's configure the router ID. Let's apply the two configuration command. First, in router 1, enable. So we need to go to configuration mode, config T, and then let us enable the OSPF in the router interface, router OSPF. The process ID will use 10, and then we will configure the router-ID. Since this is R1, we will use 1.1.1.1. Okay, that's it. And show IP protocol for protocols. So we already have the router ID 1.1.1 and OSPF 10 here. Okay, so let's move on to router number 2, the same, config terminal to go to configuration mode, global configuration mode, and then let us define router OSPF 10, process ID is 10, and then let us configure the router-ID, and then 2.2.2.2. All right, and let us and for router number 3, let us configure also, enable the OSPF, enable, go to config global mode, config T, router OSPF, process ID the same, 10, and then router ID dash ID 3.3.3. all right, and then right is to save the running configuration. So we already configured the interfaces of the router, plus we enable the OSPF, and we enable the router ID. Now in this particular scenario, right now still routers can only recognize its directly connected network. For example, R1 can ping R2 but cannot ping .9 of R2 because it doesn't have any idea of what the network of the other interface. Okay, we can show it here. if we're going to ping, I'm in R1, if we're going to ping the IP address of router number 2, 10.1.1.6, okay, so success rate is 80%. So the first ping, the other packets is actually missing, but if we're going to repeat it, it will be, success rate is 100%. But if we're going to ping the other interface, of the router, this one, 0.9, it will not work because it's in the different so we're going to ping that one, that is .9. Okay, sending 10.9 only that means success rate is 0% because we were not yet advertised the network of the other router. All right, so that is the command that we configured in this reference topology. So let's move on again to the PowerPoint. All right, so explicitly configured, we already configured the router. We already show IP protocol. It's already configured there. Now, if you want to modify the router ID, after router selects a router ID, an active OSPF routes does not allow the router ID to be changed until the router is reloaded. So if you want to change the router ID, which is already configured, you can only change that one using this command, router ID. If, for example, if you show IP protocols, your router ID is the loopback IP address, and if you want to change that one into this router ID, you can do that by entering first the router OSPF10 and then the router ID 1.1. command, and then go to privilege mode and then type this one, clear IP OSPF process, and then reset all OSPF process. You have to answer yes. Hit enter and then it will reload, and then that's the time once you check again, show IP protocols, it will change from 10.1.1.1.1 to 1.1.1. Okay, so point-to-point network. Our next, so I will stop this video in as a part 1. On next video, we're going to discuss the point-to-point OSPF network. We're going to